Hi everybody and welcome. Today we're going to be talking about identifying equations from graphs with polynomials. So we kind of touched on this in previous weeks, really focusing on intercepts instead of the entire equation. So today we kind of take this to the next level and we get ourselves to a place where we have the entire equation of the graph instead of just looking at pieces of it. We did this yesterday algebraically, so we were looking at without looking at an image. How do we get an entire equation? So today we're going to do the opposite, which is without using algebra. How do we get to an entire function just using images? So some steps to follow, and then we'll practice with doing the work of solving from there. So first, when graphing, we want to identify the x-intercepts and use these as our factors. And we also want to be sure that we identify their multiplicity. Should I spell multiplicity right? That's a long word there. As either even or odd. So remember, we have two examples. So the function either hits and goes back. So that would be an even multiplicity. So if it was like x minus 1, it would be to the second power or fourth power because that's even. The second option is if we go through, we would see it as an odd multiplicity. So like x minus 1 to the first power or third power or fifth power. So those are the two things that we want to make sure paying careful attention to. We next want to write the polynomial in its factored form with an a in front of the first term. So this is the new part, is we're going to put in an a in front of the first term, and then when we plug in a value from the function, so anywhere on the function as long as it's an accurate value, we can basically use that to solve for a. So a couple of things. We have two intercepts here. So one at 2 and one at -1. And the one at -1 is going to be an even multiplicity because it bounces back down. The one at 2 crosses through, so it's going to be an odd multiplicity. So we're writing out our factors, our y equals, when we have the opposite, so x plus 1, we're going to write it as the second power because that's even. And again, that's just reflecting that this is going back down instead of crossing through the axis, which is not the case for 2, because for 2 it does go through. The last step here, the new step, is going to be to write in an a on the outside. So from here, we just choose one value from our function. So anywhere really works. Maybe we can choose this because it's on the nice corner of a point. So that's 1 comma -8, goes down by 8. And we just plug in x and we plug in y and we solve for a. So if we have -8 for y, 1 for x, that's going to allow us to get to a spot where we can solve. Just be careful to keep track of your signs and follow PEMDAS. We want to do the inside of the parentheses first, exponent second. Multiply those two together, and then lastly, divide here. So we should end up with an answer of a equals +2. So always good just to kind of go through and double check, and that kind of allows you to see how things work out here. But if we solve correctly, we plugged in a good point, this should give us a more accurate view of our function. So our final answer here for this one is going to be 2, and then x plus 1 squared x minus 2. And that'll get us to a point where basically we practice solving, we have those intercepts, and we have a value that we can plug in now. And like I said, always good to kind of double check and make sure that we're at a good spot here, but looking like we are in good shape to work through. So jumping down, one more example here, same kind of idea. Even if it crosses through, odd if it bounces back down. And then just choose another point that we can see exactly where it lies. So sometimes an intercept is a good idea, or an edge. I always want to try to use a new point if we can. So 0 comma -16 is a good one for us. So x and y. gets an answer of a equals 4. So again, just taking that and plugging it back into where we started off. So as long as we're able to do that, we should be in good shape there, and basically just looking for kind of filling out a more accurate view of what our graph looks like here. So always good to test and double check and make sure that everything works out well. But if we plug back in another value, it should be just about exactly equal to what we see from our function here. So that's kind of the goal for today. As long as we're able to and we're comfortable finding that a value and plugging it back in, we should be in good shape to solve. So hopefully today, a little bit extra time with a bit of a shorter video leaves us some more room to go through practice questions and get some good answers and get those turned in and kind of feel good about what we're working through this week. So as always, if you got questions, let me know. But that's all we got for today.